everyone. Today we'll look into a problem on metacentric height. The problem: a solid cylinder of diameter 4 meter has a height of 4 meter. Find the metacentric height of the cylinder if the specific gravity of the material of cylinder is 0.6 and it is floating in water with its axis vertical. State whether the equilibrium is stable or unstable. This is the diagram. A cylinder having a height of 4 meter. The diameter is given, that is 4. Height is given, that is 4. And the specific gravity of the cylinder is given as 0.6. Let x be the amount of cylinder that has been immersed inside the water. Height that is immersed. Now we'll consider G, that is the center of gravity, which will be h by 2. Then center of buoyancy, which will be x divided by 2. Now we know that weight of the cylinder immersed in water is equal to weight of water displaced. Weight of cylinder immersed in water, W cylinder is equal to M cylinder into G. Mass is equal to density into volume. So density of the cylinder into volume of the cylinder into G. We'll take it as equation 1. Now weight of water displaced is equal to mass of the water displaced into G. Mass of the water is equal to density of water displaced into volume of water displaced. We'll take it as equation 2. Now the volume of water displaced is equal to area of the cylinder multiplied by height of cylinder immersed in water, that is x. Area is pi by 4 into t square into x. Now we'll consider the volume of cylinder is equal to area into height of the cylinder, pi by 4 d square into h. Now we'll equate the equation 1 and 2. Weight of body immersed in the water is equal to weight of water displaced. Density of the cylinder, specific gravity is given, so density is equal to specific gravity multiplied by density of water is equal to 0.6 into 1000. Diameter is given, height is given. Now in this equation, density of water, that is equal to 1000. Unknown is x. Now when you look into this expression, so here 1000 pi by 4 into 4 square 9.81 will cancel. So in RHS it is left with x, and LHS it is left with 0.6 into 4. So x will become equal to 2.4. Now whenever the height of the cylinder and specific gravity is given, you can directly calculate x value using this expression, that is specific gravity of the cylinder multiplied by height. So x is 2.4. Next, we have to find the metacentric height. Gm is equal to I by V minus Bg. Now in order to find the value of Bg, we'll take this reference as A, so that we can find Ag minus AB is equal to Bg. We'll see what is V. Volume of body immersed in water is equal to volume of water displaced is equal to area multiplied by x. X value is now, so A is pi by 4 into 4 square. So we'll get the answer as 30.159 meter cube. Now I, moment of inertia, since it is a cylinder, the equation is pi by 64 into d power 4. The answer is 12.56 meter power 4. Next, Bg, so Ag minus AB. Ag is nothing but h by 2, that is 4 by 2 is equal to 2. Now AB, that is equal to x divided by 2, that is 2.4 by 2 is equal to 1.2. So Bg will get it as 0.8. Now we'll substitute the value of Bg, I and V in metacentric height equation. So we'll get the Gm value as minus 0.3835 meters. The negative sign indicates that the metacentric height or the metacenter M will be below the center of gravity G. So if metacenter is below the center of gravity G, then the body will be in unstable equilibrium. Thank you for watching.